Welcome to Business Insights Daily. I'm your host Sashank. Today, we're looking at a deal that on the surface sounds pretty niche. Nvidia buying a $2 billion stake in Synopsys as part of a multi-year AI partnership to reimagine engineering and design. But beneath that headline is a much bigger question. What happens when the company that dominates AI chips starts wiring itself into the company that designs almost every advanced chip on Earth? Let's break down what Nvidia is doing, why Synopsys matters so much, and what this could mean for the future of hardware, software, and the AI economy. The deal: $2 billion for a seat at the design table. First, the basics. Nvidia agreed to invest $2 billion into Synopsys common stock at about $414.79 per share as part of an extended multi-year partnership. Synopsys isn't just a chip maker, it's a quiet giant behind electronic design automation (EDA) that software engineers at companies like Intel, AMD, and others use to design, simulate, and verify their chips. In the joint announcement, NVIDIA CEO Jensen Huang described the goal as NVIDIA's accelerated computing and AI to reimagine engineering and design across industries, from semiconductors, aerospace, automotive, industrial, and beyond. Markets reacted immediately. Synopsys stock jumped around 7% as investors saw the partnership as a long-term growth engine, but Nvidia dipped slightly, which is what often happens when a market leader spends big. There's excitement, but also questions about return integration. So, Nvidia is not buying Synopsys outright. Instead, it's taking a strategic stake and deeply embedding its AI and GPU stack into Synopsys' tools. But the obvious question is, why? Why Synopsys? Because it's the picks and shovel of the chip design. To understand the move, they have to appreciate what Synopsys actually does. Synopsys builds the tools engineers use to design the chips, check that those chips work at the transistor and systems level, simulate how they behave under difficult physical conditions, heat, electromagnetic fields, and power constraints, and increasingly model complex physical systems, optics, materials, and even molecular interactions, especially after its acquisition of ANSYS. If you're an engineer designing the next GPU, CPU, 5G modem, or automotive controller, there's a very good chance of spending a day inside a Synopsys software. Now, NVIDIA wants to plug its accelerated computing and AI stack directly into that workflow. This partnership includes using NVIDIA's CUDA and CUDA-X libraries to speed up twin compute-intensive EDA workloads, applying NVIDIA's AI physics and digital twin technology to simulations, semiconductors, aerospace, robotics, and industrial systems. And more importantly, integrating Synopsys' new agent engineer and an agentic AI system for engineering workflows, NVIDIA's Nemo agent kit toolkit and Nemotron tools make part of the design process more autonomous. Instead of engineers waiting hours and days for simulations in traditional GPU cluster, you can run them on NVIDIA's GPU with agentic AI suggesting that optimization, design alternatives, and issues are being caught earlier. This strategic logic is simple but powerful. If NVIDIA becomes a difficult AI engine inside Synopsys, then NVIDIA is no longer just supplying chips to the world, it's helping design them too. The bigger pattern: NVIDIA's web of AI deals. This isn't happening in isolation. Earlier this year, NVIDIA announced a commitment to invest up to $100 billion in OpenAI over time, coupled with the deal to supply GPUs and systems for at least 10 gigawatts AI data centers, plus a $5 billion partnership with Intel to co-develop AI-optimized CPUs and bolster Intel's manufacturing ecosystem, effectively hedging its bets on health of the broader chip supply chain. So the Synopsys investment fits a broader pattern: own the AI hardware, secure demand through massive customer investments, and plug into the design tools that shape the next generation of chips. It's almost like Nvidia is building an AI OS for the entire computer stack, from design, production, to data center deployment and model training and inference. So the curious question is, At what point does this stop being partnerships and start to look like end-to-end infrastructure dominance? What this means for engineers and industries. For engineers, this could be transformative. Synopsys has already reported huge speedups when moving certain simulations to Nvidia GPUs, like up to 500 times faster in some fluid and physics simulation using Nvidia's AI physics tools versus traditional CPU only approaches. When you add agentic AI on top, systems don't just run in simulations, but help decide which ones to run. Suddenly, they're not just compressing time, but changing how work is done. Think about automotive teams designing new EV power electronics, aerospace companies modeling airflow and materials, and chip designers trying to squeeze more performance out of smaller geometries. If the tools become significantly faster and more intelligent, the bottleneck shifts from compute to creativity. How many good ideas can your engineers generate and test? Nvidia and Synopsys want to be the platform where those ideas are born, validated, and refined. Of course, there are risks and tensions here. For Synopsys, partnering deeply with Nvidia could raise questions for other chip makers to compete with Nvidia. Will AMD and GPU rivals be comfortable relying on EDA tools that lean heavily on a competitor stack? Synopsys will have to balance openness with the depth of its Nvidia integrations. For Nvidia, a $2 billion equity stake is a big bet that the EDA in digital engineering will be a major growth engine. If regulation, computer pressures push back against too much vertical integration, Nvidia might face scrutiny for being everywhere in the AI value chain. And for the market, the more Nvidia becomes indispensable at training time, inference, and now design time, the more customers and regulators will look for alternatives, whether it's custom ASICs, rival GPUs, open EDA stacks. If the best engineering tool could be tightly coupled to high-end GPUs and AI agents, smaller firms and emerging markets might struggle to keep up unless pricing and access are designed thoughtfully. Either way, a $2 billion stake is more than a financial headline. It's Nvidia saying, we don't just power the AI revolution, we want to make sure that the next generation of the physical world gets designed. This is Business Insights Daily. Thank you for listening. I'm Sishank, your host. And next time you hear about some breakthrough chip or aircraft or even robot, you might ask yourself, was there a little bit of Nvidia and Synopsys inside the design long before it ever reached the real world? Thank you.